This one here, we are going to establish whether the functions f and g are inverses of one another. So the function here is f of x equals x plus 3 equals 2x minus 1, and g of x equals x plus 3 over 2x minus 3. This question is not asking us to find the inverse of f and find the inverse of g and then see whether they have the same inverse. No, it is saying determine whether this function is the inverse of this one and this one is the inverse of this one. That is basically what this is asking us to do. So how do you find or establish whether a function is an inverse of another? You have to use composite functions. You find the composite of these functions. Use composite function concept, i.e. find f circle g of x and g circle f of x. If these two are equal, then this is an inverse of this one and this one is an inverse of this. That is basically what you are asked to do. You check whether two functions are inverse of each other by finding the composition. So here we are going to find f circle g of x, which is f of g of x, x plus 3 over 2x minus 3. So when you say f of g of x, you start from right going this way. You take g of x, that is the one that you substitute in f. It's like when you have f of 2. When you say f of 2, we are saying take these two, substitute in this function. Where there is x in this function, you put a 2. That is what we are being asked to do. So this one here, our f of x is this. So where there is x, this is where there is x, plus 3 all over 2x minus 1. So where there is x, this is my x. I'm going to put this. I'll take this and put it here and put it there. That's what I'm going to do. I'm not saying when you write this in a test or in an exam or in an assignment, you have to do these boxes. This is for emphasis purposes. So this one here, it will be x plus 3 all over 2x minus 3 plus 3 all over 2 times x plus 3 all over 2x minus 3 minus 1. So this is my x plus 3 in my f of x function. Remember, it's f of g of x. You take g of x, you substitute it here. My g of x is this. I replace where there is x, I put all of this. So now I'm going to simplify this. How do I simplify? So I'm going to do it here. Simplify and then get back there and do the substitution. X plus 3 all over 2x minus 3 plus 3 over 1. So these are two fractions. 3 is the same as 3 over 1. I'm dealing with the numerator. So this is the numerator. After dealing with the numerator, I'll go to the denominator. After dealing with the denominator, I then go back and substitute here. Replace the numerator with the new value. Replace the denominator with the new value. So here, I'm looking for the lowest common denominator of this is 2x minus 3. If you have 1 over x plus 1 over 3, the lowest common denominator is 3x. So that is the one that you put here. So this one into this, it goes once. And this will be times x plus 3, which is x plus 3. Plus 1 into this, it goes 2x minus 3 times 3. So that will be 3 times 2x minus 3. And then I have to remove the brackets. So the top one, x plus 3 plus 3 times 2x, 6x. 3 times minus 3 minus 9. I'm removing the brackets. 2x minus 3. right? And then this one I have to collect like terms. X plus 3x, it is 7x. Positive 3 minus 9, it is minus 6. And this is all over 2x minus 3. So this is the numerator. This is not the answer. We have paused here so that we can deal with these. We can simplify this. Now let's take the denominator. Let's take the denominator. So this is the denominator. The denominator is 2 times x plus 3 all over 2x minus 3 minus 1, right? So this is the denominator. So when you have this 2 outside the brackets, this is the same as when you have, let me do it here. So when you have 2 times half, you multiply the numerator only. Why? Because this 2 is the same as 2 over 1. This one, if I'm to write it as a fraction. And this one, it's a half. Brackets means times. So this will be the same as 2 over 1 times 1 over 2. And then how do I do the multiplication? It will be 2 times 1 over 1 times 2. So you can see that these 2 outside, it only multiplies the top. Same applies to this one here. When I have 2 outside, there is a fraction, I only multiply the numerator. So this will be 2x plus 6 all over 2x minus 3. This 2 does not multiply both top and bottom. It only multiplies the numerator. This is minus 1 over 1. And then here, you look for the lowest common denominator. It is this term here. 1, it does not affect anything because you multiply these 2. If there are variables involved, to get the lowest common denominator, you multiply the denominator by this denominator. Then you say 2x minus 3 into this, it goes once. 1 times this is 2x plus 6. And then this is minus 1 into this, it goes this times this. So it is minus 1 times 2x minus 3. You put it in brackets. Now, let's remove the brackets. 2x plus 6 minus 1 times 2x. Negative times positive, it's minus 2x. Negative 1 times negative. Negative times negative is positive all over 2x minus 3. Now we collect like terms. We've got 2x, we've got minus 2x. Negative 2x here cancels this 2x. 6 plus 3, it's 9 over 2x minus 3. So this is the denominator. And this is the numerator. We now go back and take this, put it here, take this one, you replace it with this one. Because this thing here, we broke it into the numerator and denominator. Now we go back. So this will be 7x minus 6 all over 2x minus 3. This division sign here, I can write it as a symbol. This will be divided by, and then I take this one. This will be 9 over 2x minus 3, because this is the denominator after simplifying it. So this division sign, when you divide two fractions, you change it to multiplication. Okay? And then you invert these. You invert this. So this is 2x minus 3 over 9. So this one cancels this. You remain with 7x minus 6 all over 9. So this is my f of g of x. So that is my f of g of x. So let me pause this one, and then the next video I'm going to find g of f of x, and then I compare them. If they are the same, then I'll conclude that one is the inverse of the other. Thank you.